Hello and welcome. This is the third lecture of human-computer interaction. Up till this point, we have discussed so many things that uh, in human-computer interaction, the interaction is with the task rather than with the machine with the help of the machine. Now, the overall crux of human-computer interaction is based on the designs which are more interactive for the human, and the overall design focus is on the motor control based on the human properties, that how humans interact with each other. So let's begin with, as human is the central character in any discussion of the interactive systems, so the requirements of the user should be the first or the topmost priority in designing any interactive system. Now, all the areas of human psychology coming under the general banner of cognitive psychology, they can help out in designing such systems. But we have to be more focused towards the capabilities and limitations of humans as well as the design systems. Because once we understood that what are the capabilities of humans, where is the limitation of human uh, system, then we can design the uh, interactive design, either complementing it or either imitating the same designs which are available with the humans. We have already discussed in our previous classes about the input output channels. So the basic idea is that in order to perform the input output between the human and the machine to which we want to interact, there are certain channels, and those channels can be matched with the senses which are available with the humans. So let's see that how it is going to work. Vision, hearing, and touch. These are the primary senses with the human. Now we'll be understanding the roles and limitations of these primary senses, and going on, we'll be considering those roles and limitations with the perspective of a motor control. Starting with the vision. So, human vision is a highly complex activity with a range of physical and perceptual limitations. Yet, it is the primary source of information for the average person. Whatever information we perceive is, on the first hand, will be captured or gathered by the vision. So we can roughly divide visual perception into two stages: the physical reception of the stimulus from the outside world, and secondly, the processing and interpretation of that stimulus. We have already gone through in detail with the human eye perspective, that what is the designing of human eye and how do we perceive things. This we have already done in our previous class. But and we have gone through one exercise of optical illusion as well, if you remember. So optical illusions, they highlighted the difference between the way things are and the way we perceive them. And in interface design, we need to be aware that we will not always perceive things exactly as they are. So the system has to be designed in such a manner that it should receive the stimulus from the outside world and process it accordingly as the human brain does. Now, we have up till so far we have concentrated on the perception of images in general, right? However, the perception and processing is of text is also a special case, which is very important to interface design, because as you can see, as of now, when I'm interacting, I'm showing you certain text. So in any system design, interactive system design, it is basically that we'll be showing certain images and also combination of text. Okay, so obviously we will be requiring some textual display in all the machines. So we'll therefore look at the reading perspective. There are several stages in the reading process. First, the visual pattern of the word on the page is perceived. As you can see as of now on the screen, you are seeing the visual patterns of the word. It is then decoded with reference to an internal representation of language, that you understood that it is written in English language because the alphabets, the curves that I have used, they are representing the language perspective. And the final stage of language processing includes the syntactic and semantic analysis and operate on phrases or sentences. That means whatever I have written, first you have noticed with your eyes the pattern, then you realize that it is written in English with the language perspective, then you further focus on that it is making certain sense, that the spellings which I have written, the phrases, the sentences that I have written, it is making certain meaning. Okay, if I jumble them, then it is going to be difficult to understand that part. Now, we are most concerned with the first two stages of this process and how they influence interface design. During reading, the eye makes jerky movements called as saccades, followed by the fixation. So our perception occurs during the fixation period, which account for approximately 94% of the time elapsed. That means first we have the movement and then we fixate, and in this fixation, the duration, the perception occurs in this fixation time. The eye moves backwards over the text as well as forward, and this is known as regression. If the text is complex, there will be more regressions. Adult reads approximately 250 words a minute. It is unlikely that words are scanned serially, character by character, because if you have seen some pattern or some text which you usually read it on and off, then it is easy for you to grasp that quickly, right? You can also understand this by uh, taking the example of that the familiar words are recognized using the word shape as well. And that is why when we write something in all capital letters, sometimes it is confusing to understand that text. Or maybe if I say write everything in capital letters, then sometimes people forget about the spelling part. They miss that. So our reading speed and the accuracy depends on the shape clues as well as the what is our call as the familiarity of the words. Okay, and if we have seen some text for the very first time, more and more number of regressions will take place to understand that. Let's move ahead with the another sensory part, which is hearing. Hearing. The sense of hearing is often considered as secondary to sight, but we tend to underestimate the amount of information that we receive through our ears. If I say that as of now you close your eyes for a moment and listen, what sounds can you hear? What are they coming from? What is making them? I'm sure as of now when you are watching this video lecture, You must be either present in somewhere in classrooms, you must be present in your room, maybe some fellows are traveling and they are listening it. So maybe some person is working in kitchen and they are having just utilization of mixers or juicers. Some people are on the bikes if they are sitting in roadside view of the balcony. So you get so many information, so many sounds outside from the outside world. And if I ask you, based on your knowledge or past skills, maybe for the most of the sounds you will be able to recognize and say that this sound is coming from this device or this room, and this is the sound of this particular thing. Okay, so the auditory system can convey a lot of information about our environment. But how does it work? Let's focus on the first part, and that is the human ear. Just as vision begins with the light, hearing begins with the vibrations in the ear or the sound waves. The ear receives these vibrations and transmits them through various stages to the auditory nerves. So the ear comprises three sections, as you can see, known as outer ear, middle ear, and inner ear. Outer ear, as the name is indicating, it is the visible part of the ear, and it also contains, or it also has, two subparts: pinna and auditory canal. Now pinna, which is the structure that is attached to the side of your head, and the auditory canal along which sound waves are passed to the middle ear. We are talking here about the cavity in between. The outer ears serve basically two purposes. First one is it protects the sensitive middle ear from the damage. The auditory canal contains a wax which prevents all type of dust, dirt, or over inquisitive insects reaching to the middle of the ear. Okay, so it sometimes acts as the protective guard. Now it also maintains the middle ear at a constant temperature. It varies because if there are sudden changes in the temperature outside, it maintains that temperature. Secondly, the pinna and the auditory canal serve to amplify some of the sounds. Now, let us understand that what does this middle ear is about. The middle ear is the small cavity which is connected to the outer ear by the time. You can pronounce it as you want. Tympanic, sometimes they call, or tympanic, sometimes they pronounce tympanic membrane. Okay, or eardrum. That means, as I'm saying, this is a middle ear. That means middle will be connected in both the direction, the outer one and the um, uh, inner one. Okay, so to the eardrum on the outer side, from the outer side, and to the inner ear by cochlea. We pronounce it as cochlea. The spelling is written on the screen, C-O-C-H-L-E-A, cochlea. Okay, now within the cavity there are ossels. I'm sure you must have heard that ossels are the smallest bones in the body. Okay, so you must have heard that ossels are the smallest bone in the body. Sometimes in GK questions it has been asked which is the smallest bone in the human body. So this is the bone which is inside the ear. Okay, so sound waves pass along the auditory canal and vibrate the eardrum, which in turn vibrates the ossels. Okay, which transmit the vibration to the cochlea and so into the inner part of the ear. Now you must be looking at that the sound is traveling from here to from the outer ear to the middle ear, then to the inner ear. So there is so much relay in that. This relay is required because unlike the air-filled outer and the middle ear, the inner ear is filled with a denser cochian liquid. Okay, so if passed directly from the ear to liquid, the transmission of the sound wave would be very poor. So there is a relay which is created. Now by transmitting them via the oscills, the sound waves are concentrated and they will be amplified. The waves are passed into the liquid filled cochlea in the inner ear, and within the cochlea are some delicate hair-like cells or cilia that bend because of the vibrations in the cochlear liquid and release a chemical transmitter which causes impulses in the auditory nerve, because at last it has to be transmitted to the auditory nerve, and once the neurons will fire, then only the interpretation will be done. The processing will be done after that. Let's focus on the sound processing part. Okay, up till now we have understood that sound is changes or vibrations in the air pressure, but it has a number of characteristics which we can differentiate before looking into that how this sound is processed. You must have heard a term called as pitch. Pitch is the frequency of the sound. A low frequency produces a low pitch and a high frequency produces a high pitch. You must also have heard one term called as loudness. So loudness is proportional to the amplitude of the sound. Okay, timbre relates to the type of sound. That means a sound which is having same pitch and loudness, but it is being made by different instruments, or they vary in the timbre. So we can also identify sound's location because we have two ears receiving uh, exactly same functionality and receiving slightly different sound. Okay, and owing to the time difference between the sound reaching to the two ears, because if sound is coming from one direction, it will reach to the one ear first, and then it will reach to the second ear in some time difference. And the reduction in intensity is caused by the sound waves which reflect from the head. Now, we can say that the human ear can hear frequencies from about 20 Hz to 15 kilohertz. It can distinguish frequency changes of less than 1.5 Hz at low frequencies, but is less accurate at the high frequencies. The idea of processing the sound is that different frequencies triggers activities in neurons in different part of auditory systems, and they cause different rate of firing of nerve impulses which result in understanding of a different type of sounds. The auditory system performs some filtering of the sound receives, allowing us to ignore the background noise and concentrate on the important information. And this is the concept which is implemented in on the mics or on the Bluetooth headphones or headsets. I'm sure everyone must be wearing as of now, and while buying you must have seen on the packet it has a noise cancellation feature. So what is that noise cancellation? That means concentrate on the important information and filter out and lower the background sounds or the sounds which are different from the main original sound. Okay, I think you you can say that I have written here on the screen the party effect example as an example. So we as a human have a selective kind of hearing, and the party effect is, suppose we are in the party which is too loudy and noise is there, we are crowded by people, everyone is discussing something, right, just like a fish market, and suddenly if somebody has spoken your name across that crowded party room, then you will hear it. Although there are a lot many sounds over there, okay, but still this is called as cocktail party effect, that human has a selective hearing based on the things, based on the patterns, or based on the information which is important to them. They tend to listen in the crowded place also. Now, however, if sounds are too loud or frequencies too similar, we are unable to differentiate the sound. This is the limitation of human ear. Okay, so as we have seen up till this, the sound can convey a remarkable amount of information, right? So we can say that it is very good to potentially use in the interactive design, and more importantly, whenever we have to put some kind of notification or warning sounds. I'm sure during hearing this overall video, you must have heard my phone was ringing. Sometimes you know the notification alerts was pinging in between, and the sound must have recorded in the video itself. So for this type of alerts and notifications, the sound will be more affected rather than the textual or image kind of data which will be covered with the vision part. Okay, so because the multimedia is the exception, which may include music, voice commentary, and sound effects also. So we are not focused here in creating the sound with the devices like MIDI devices. We are here interested that how in interactive system design we can utilize this sound effect. Now, the ear can differentiate quite subtle sound changes and can recognize familiar sounds without concentrating the attention on the sound source. Like if suppose your friend is calling you, your mother is calling you, you are familiar with the voices, and the sudden reply is, yes, I'm coming, what's the matter? Okay, so this suggests that the sound could be used as more extensively in the interface design and convey information about the system state. That would be very effective if we do so. So now we have one work exercise for you all in which you have to suggest some ideas for an interface which uses the properties of sound effectively. Now you can cover the speech sound as well as the non-speech sound. This is up to you. Please come up along with your suggestions. Thank you for watching this video.